kids! I am Teacher Sheila and I am your science teacher for today. Do you want to know more about science? Come and join me. Let's explore together. So our topic is about constructing models. Before we go on to our discussion, let me ask you some questions for you to answer. Number 1. What is scientific model? Number 2. What are the types of scientific model?
When most of us think of models, we either think of this or different sized versions of things that exist in real life made out of plastic. But there are models that scientists use which are very different. They are made out of math.
A model is a mathematical way of representing the real world in some way. Maybe it's the climate, maybe it's a population of fish, maybe it's an ecosystem of many different species all interacting.
And it all exists because of complex mathematics. Think of a video game, but where the virtual world is a process, like a weather system or an ocean current system.
We can sort of play in a virtual world as it relates to the process that we're interested in, and essentially play that game and test lots of different scenarios and see what the outcome is going to be.
And just like a video game isn't exactly like reality, a mathematical model isn't exactly like the real world. But because they can approximate key aspects of the real world, models are crucial tools for scientists.
So models are useful for a few different things. One is for building intuition, when we just want to quickly understand how a couple of things might fit together. They're also very useful for filling in process, where we have observations maybe here and here, but don't know what's going on in between. And then third, for peering into times or places where we can't see, either the future or maybe a part of the world we haven't been to yet.
Models can give you a quick intuition about how complex natural processes work. Usually that means you start off with information, and that depends on what question you're trying to answer and what system you're looking at.
You need to have information about where the model is, so how deep is the water. You need to have information, if you're looking, as I do, at ocean currents, what are the conditions that are around your model? So is it in the middle of a huge ocean, or does it have a big river that's coming out at a particular continent? And then you need information about what the atmosphere is doing. Are there huge winds here, or is it usually very calm? Do those winds change direction? So you put all of these ingredients together, and then you run the model and you see what you get.
Modeling allows you to run things in a simulated world, an alternative kind of reality that's mimicking the reality of the system you're studying, but you're actually able to test all of those parameters at once. And that's extremely powerful. Models also help you make linkages and make connections between sets of data, which is actually more complicated than it sounds.
The model brings something extra because you build into the model some laws of physics, some principles. So imagine that there's a surface, a hilly surface, and we have a ball on top of one hill and a ball on top of another hill. And if we just took those as two data points and said, where's the third ball, we might predict that it lies immediately between them, right over a valley. But by building a model that knows about gravity and the surface of the land, the model would place the third ball somewhere in the valley, not just directly between the two observed points, right?
So let's say you're talking about viruses and you have data from one place and data from another place. A model helps you predict what the data should be here where you haven't gone yet. And then you can go out and actually see if your model is correct. Scientists run experiments to test hypotheses, and most often scientists collect data in the real world by running a physical experiment and seeing if the hypothesis they're testing holds up to reality. And then they collectively form the basis of a theory that is used to explain how the natural world works and predict things that happen. Models are a great way to run an experiment that would otherwise be impossible to run.
You know, when we're trying to understand how the world works, we can take a few different approaches. We can go out and we can build an experiment. Maybe it's in a lab, maybe it's even at a small scale in the natural world, or we change something and we observe what happens. Or you can go out and just take lots of observations and observe patterns across space or patterns through time. But both of those, unfortunately, are limited.
For example, if you're studying the cosmos, you can't wait millions of years for two galaxies to collide. If you're studying the effects of ocean viruses, you can't physically monitor every microscopic cellular interaction throughout the entire ocean. The real world has time and space limitations. Models, on the other hand, do not, which means you can go do experiments that can't be done in the real world.
What would be really cool is if you could just come along one day and just remove all the viruses from the ocean, see how the ecosystems respond, and then come back a week later and put them all back in and see if there are differences. Right, we can't do that because there are so many viruses in the ocean is so large it would be impossible to do that, but we can in a model.
So, models are crucial in three ways. They allow you to get a quick glimpse of a complex system. They allow you to connect the dots between the data you've collected and test a hypothesis that you've come up with. And finally, they allow you to use these data-supported models to predict things that haven't happened yet, or scenarios that are what-ifs that would be impossible to test otherwise. Importantly, models can be modified to incorporate new evidence as it becomes available, so they are continually refined and getting closer and closer to simulating reality. And here's why mathematics is so important to science. With the right mathematics, you can visualize a phenomenon and then share it with other scientists. Now scientists can work together to make discoveries and solve real-world problems.
Models are going to be most fun and most valuable when they're rooted in real-world data, when they're informed by empirical observations, and when they in turn make testable hypotheses and predictions that can be addressed in the field or in the lab. That's where I think the real payoff is.
Constructing models. Models have a variety of uses, from providing a way of explaining complex data to presenting as a hypothesis. There may be more than one model proposed by scientists to explain or predict what might happen in the particular circumstances. Often scientists will argue about the rightness of their model, and in the process, the model will evolve or be rejected. Building a model. Scientists start with a small amount of data and build up a better and better representation of the phenomena they are explaining or using for prediction as time goes on. These days, many models are likely to be mathematical and are run on computers, rather than being a visual representation, but the principle is the same. Using models for predicting. In some situations, models are developed by scientists to try and predict things. The best examples are climate models and climate change. Humans don't know the full effect they are having on the planet, but we do know a lot about carbon cycles, water cycles, and weather. Using this information and an understanding of how these cycles interact, scientists are trying to figure out what might happen. Models further rely on the work of scientists to collect quality data to feed into the models. This time, let us try to check your knowledge.
Hello there. It's wrap-up time. I can do it.
For your final activity, attach a picture of scientific models. Describe its usage and how it is used in presenting hypotheses and predicting situations.
Good job!
That's all for today, kids. Thank you for your participation. God bless and keep safe, everyone.
Good job, good job, good job today. You did a great job today. Clap, 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 sing with me. It's time to say goodbye. Goodbye, 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 my friends. You did a great job today. Clap, 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 sing with me. Let's wave our hands goodbye.